In the experiment flakiness index test, the weight of the sample W is given to be 1200 gram. That is, we had taken the total weight of the sample as 1200 grams before our experiment. In the very first column, we have the sieve sizes mentioned through which the aggregates were passing and the aggregates were retaining. For the first column, it gives the aggregates which were passing through different IS sieves. Those sieves were 20 mm, 16 mm, 12.5 mm, and 10 mm. And also the aggregates which were retaining on different sieves like 16 mm, 12.5 mm, 10 mm, 6.3 mm are given in the table 2. Sorry, not the table 2 but in the column 2. Now coming to the thickness of the gauge size, the width of the slots corresponding to 20 mm and 16 mm sieve can be calculated as 3 by 5 into the sieve sizes 20 plus 16 mm by 2 is equal to, that gives us to be 10.8 the width of the slot. Likewise, for corresponding sieves, the width of thickness slots can be calculated. Now, the next column 5 shows the width of aggregate passing through the thickness gauge. So, we have taken two samples, sample 1 and 2. In the sample 1, the weight of the aggregates which were passing through the thickness gauge are measured from 20 to 16 mm, that is 72 grams, and next is from 16 to 12.5 thickness slot. The aggregates which were passing is recorded to be 246, and so on. The total weights of all the sample 1 and 2 are calculated. Now, what is flakiness index? The flakiness index is the total weight of material passing through thickness gauges divided by the total weight of the sample taken in percentage, and that gives for the first sample our percentage of flakiness to be 36.50, and for the second sample the flakiness index percentage is given to be is calculated to be 34.8. Now the average flakiness index in percentage of the two is calculated to be 35.65 percentage. We must remember that the flakiness index in excess of 35 to 40% is considered undesirable, but in our case it is not undesirable and our aggregate is fine.